Okay, for part B of question number 34, A matrix is given. We have to show that the transpose of A into the, the product of the transpose of A and A inverse is equal to this. So let's find out the transpose first, or let's find out the determinant first to check whether the A inverse exists. And to find the determinant of A, this is square matrix of order 2. So this is 1 minus 1, 1 into 1, and minus of cot x into cot x. So this is 1 plus cot square x. So determinant of A is equal to 1 plus cot square x, and we know that this is equal to cosecant square x. All right, now let's find the adjoint of A. And because this is a square matrix of order 2, so to find the adjoint of A, we will just keep these elements as it is and interchange the sign for these two. So this is cot minus cot x and this is cot x. So this is the adjoint of A for square matrix of order 2. And now we have to find A inverse. So A inverse is adjoint of A divided by determinant of A. So adjoint of A is 1 minus cot x. This is 1 and negative cot x, and this has to be divided by determinant of A, which is cosecant square x. Okay, which gives me A inverse as, so this is 1 by cosecant inverse. Okay, let's keep it as it is. Now let's find out. So this is our A inverse, and let's find out the transpose of A. So transpose of A is changing the rows into columns. So trans A is this is a matrix. So this is 1 minus cot x, changing that row into column, and 1 minus cot x and cot x 1. Okay, this is the transpose of A. So A transpose we have got, and now let's get the product of A transpose and A inverse. So this is 1 minus cot x into 1. This has to be multiplied with A inverse. So this is A inverse, and this is 1 minus cot x 1, and I will just keep 1 by cosecant square x here. Okay, so A transpose into A inverse is equal to 1 by cosecant square x. Okay, this into our first column, so 1 into 1 is 1, and negative cot square x. This with the second column, so negative cot x and negative cot x. This is cot x plus cot x. This is negative cot x. So cot x, this is cot x and cot x. So this is cot x into cot is cot square x, and 1 into 1 is 1. Okay, finally we can write it as 1 upon cosecant square x, and 1 minus cot square s 2 cot x. Okay, this is now 1 minus cot square x minus 2 cot x. This is 2 cot x, and this is 1 minus cot square x, and this has to be divided by cosecant square x. So let's try to simplify this. So this is 1 minus cot square x upon cosecant square x minus 2 cot x cosecant square x. and 2 cot x upon cosecant square x. This is 1 minus cot square x upon cosecant square x. Okay, now we have this identity, or let's try to simplify this. 1 minus cot square x upon cosecant square x. So we know that cot is cos upon x divided by cosecant is sine square x. So this is, let's take the LCM. So this is sine square x minus cos square x upon 1 by sine square x. So we are left with sine square x. So this is now equal to sine square x minus cos square x. And this, let's try to simplify this. The second term, so this one is minus 2 cot is cos by sine x. Cosecant square is 1 by sine square x. So this is now equal to 2 is equal to 2 cos x into sine x. So 2 cos x into sine x, which is equal to negative of sine 2x, because 2 cos x into sine x is sine 2x. So this is negative sine of 2x. Okay, for this one, this is cot x. Cot x is cos x by sine x. Cosecant is 1 by sine square x. This gets cancelled. So this is once again 2 cos x into sine x, and 2 cos x into sine x is sine 2x. So this is sine 2x. And we have already simplified this. So this is equal to sine square x minus cos square x. Okay. Now we know that cos 2x is equal to cos square x minus sine square x. So if we take negative out of this, so this is sine square x minus cos square x, and this becomes negative cos 2x. So this is equal to negative cos 2x. This is equal to negative sine 2x. This is sine 2x, and these two are equal. So this is once again also equal to negative cos 2x. So this is now, that means the transpose of A into A inverse is equal to my negative cos 2x, negative sine 2x, sine 2x, and negative cos 2x, and that is equal to RHS.